Problem number 3. School newspaper claims 35% of students have credit card debt. You think it's different. Different. You're not sure if it's more or less. You just think it's different. Simple random sample, 91 people, 36 say they have credit card debt. Okay, once again, see if you can write down the null and alternative hypothesis without me. So maybe pause right now and write something down. Okay. So the null hypothesis, remember the null is always going to get an equal sign, so P should be equal to something. And the school newspaper is claiming 35%, so 0.35. Now the alternative hypothesis should look just like the null, except we need a different symbol, either a less than, a greater than, or a does not equal. And let's see, they say different. We think it's different. So that. So when it was a less than or a greater than, we call that a one-tail. So with that symbol, we would call this a two-tail test. Two-tail. That'll make more sense as I get into the critical values. But let's do our test stat now. So I'm going to throw everything into the calculator. Z equal. So let me just bring my calculator over here. On. So one prop Z test, so go to stat, slide over to test, slide down to one prop Z test. Okay, P, the null says it should be 0.35, so 0.35. Okay, enter. And then X out of N. The problem says we simple random sample 91 students and 36 have credit card debt. So that's what, 36 out of 91? So 36 for X. N is always bigger, 91, 36 out of 91. Okay, enter. And then look at your alternative hypothesis. It's the does not equal symbol. So you see how we have to choose either does not equal symbol or less or greater than. So choose the does not equal symbol, enter. And then let's slide down to calculate, and you hit enter. And it gives us a Z value of 0.912. So I'm just going to call it 0.91. 0.91. Critical values, I'm going to come back to that later. The P value is not the P hat, but the P value is 0.3617. 0.3617. Okay. So now, statistical conclusion. Alpha, significance level was 5%, so alpha 5% or 0.05. How does my p-val, so here's my p-val, how does that compare to my alpha of 0.05? So this 3617 is way bigger, so my p-val is greater than my alpha. Alpha's hard to draw sometimes. Alpha, oh, so much better. Okay, so p-val greater than alpha, so I would say do not reject HO. Some books would say fail to reject HO. Our book says do not reject HO. Okay. Well, we're being very careful with our words, folks. I'm going to talk more about this later, but notice we're being very careful with our words. We accept nothing. We either reject or we do not reject. It's kind of like in a court of law. Technically, no one is found innocent. You're either found guilty or not guilty, right? So either we reject HO or we do not reject HO. So if you do not reject HO, that means you're kind of, I don't want to say accepting it, but we're kind of stuck with it. There was not enough evidence to suggest this guy. Do not reject HO. Oh, you mean we're stuck with HO? Yeah, we're stuck with this idea. There's not enough evidence to suggest this. Okay. Not enough evidence to suggest. And then let's put that into words. So this is all about students with credit card debt. So not enough evidence to suggest that the percentage of students with, I read it out, with card debt is different than 35%. Okay. Do not reject HO. We're stuck with the HO. So if we're stuck with this, there's not enough evidence to suggest this. There's not enough evidence to suggest that the proportion percentage is different than 35%. Not enough evidence to suggest the percentage of students with credit card debt is different than 35%. Aha. Okay, so again, the book keeps asking for critical values. We did the whole problem without critical values, but for the record, had we done this, the classical approach, critical values, so you draw a bell curve. Let's use black ink. Draw a bell curve. Alpha's 0.5. Do we put the 0.5 on the left tail, the right tail? Oh, it's a does not equal. We put it on two tails. Aha, that's why it's two tails. And if there's 0.5, then we got to chop it in half. So there's 0.025 over here, and there's 0.025 over here. So if you go hunting for 0.025, you're actually going to find it, 0.0250. So this is a negative 1.96, and over here would be a positive 1.96. So our critical values would be plus or minus 1.96. So those would be our critical values. Again, go hunting for 0.0250, and you'll find that it corresponds to negative 1.96. So by symmetry, this would be positive 1.96. Another way I did this really quickly in my head was if there's 0.5 shared in the two tails, how much is in the center? Doesn't that mean there's 95% in the center? And if there's 95% in the center, I have it memorized that the critical value is 1.96. Aha. Okay. Hope that made sense. Boop.